This lecture will discuss measurement systems and how those relate to quality assurance and to graphic communication. So to start, when we talk about measurement, we're talking about the process of determining a dimension, a quantity, or a capacity. And really any measurement that we might take can be categorized into one of those three areas. So a dimension, we might measure the length of a board and identify that it's 8 feet long, and that tells us the dimension of the board. Quantity, we could identify that this box of screws has 100 screws in it. Or a capacity, we could identify a gallon of milk as a capacity, as a measurement of liquid in that particular container. So we have various standards of measure, and standards are important because they provide consistency over geographic areas. Prior to the Industrial Revolution, we had a lot of measurements being established, but those measurements may have been isolated into that local community because there wasn't trade from one community to the next or from nation to nation. It was very localized. But as we began to trade at a larger geographic region, it became important that we had some type of standards of measurement. So that one thing was identified as a foot in one location, when we went to another location, we could say that it was a foot and it was exactly the same. So there have been various standard organizations that have been established through the years in order to provide this consistency. So one of those standards organization is ANSI, the American National Standards Institute, and they have a variety of standards that they have established for various industries. For example, in a technical drawing, ANSI has established what practices and how we are going to draw different things on a technical drawing, how we would measure or identify different parts, and so they established those standards. They also have a standard for safety glasses, which is identified as Z87. So if a company is going to create a pair of safety glasses, the industry standard to meet is the Z87. And in order to conform to that, the company is going to have to use a certain type of material. The glasses are going to have to cover so much of the eyes and so forth in order to meet that particular standard. But when the standard is in place, that allows consistency across the board, in that you know that if you're buying a pair of safety glasses that has Z87 identified on them, that they're going to meet that minimum standard of protection that you're going for. Another standards organization is ISO, the International Standards Organization, and they have various standards that they identify, such as the ISO 9000, which is a quality assurance standard that a company can certify, or they can certify under or try to meet that standard to identify themselves as ISO 9000 certified. IEEE is another standard for electronics parts. For example, IEEE 1394 is a standard that identifies, in this case, this is a FireWire cable, and it identifies that that particular cable is going to transfer data at a minimum standard and so forth. So standards are important to be able to create consistency and communicate to what level that particular part or component has been developed to. So in terms of measurements, we have two measurement systems out there. We have the U.S. customary system, which was developed from the English units and used throughout the British Empire. It was established over a long period of time and it dates all the way back to the Roman Empire and then moving forward into the British Empire. But throughout that time, you had different units that were being established, from units for distance, units for length, units for liquids, and so forth. But the challenge with this particular system is there was no real pattern between the units, and so it made it kind of complicated to use. Then we also have the metric system, which was developed in France in the early 1800s, and this system was kind of developed in contrast to the English units that were being used at a time, and they wanted to establish a more standardized measurement system that used a typical pattern, and that pattern was a decimal system of measurement based on the number 10. And so this metric system, or this system of measurement, became widely used throughout Europe and other countries throughout the 1800s and 1900s. The International System of Units was established as kind of the standards organization to oversee the metric system and to communicate to make sure that what in one location a meter was the same as in another location. This International Systems of Units, again, it was developed in France, and the French word for that is Systems International, which is why it's identified as SI on a particular drawing or unit, and that identifies that this particular part or drawing or whatever it might be falls under the metric system. So we have these two systems in place. At this point in time, really U.S. is the only nation left, for the most part, that is using the customary system. All other countries, or the majority of other countries around the world, have all adopted the metric system. There are a variety of reasons why the U.S. is still using the customary system, and though the government did provide or did kind of initiate a push back in the 60s and 70s to transition to the metric system. It was a voluntary push, and really there wasn't a lot of buy-in to it. And it's not just basically because of stubbornness, though that certainly may be a part of it. There is the component of it would take a lot of time and expense to transition everything over from the traditional customary system to the metric system. But as you've experienced, there certainly is a growing trend of using the metric systems. If you look at your pop bottle now, it'll be identified as liters as well as the ounces. And so we're seeing more and more units being transitioned over to the metric system, and I believe certainly over the next 10, 20, 30 years, we're going to see more and more things moving to that metric system. As we continue with worldwide trade and the global environment, whereas the rest of the world is using the metric system, the United States is going to have to continually begin that transition to adopt more and more of the metric system. So to compare the two, you can see just taking a couple of different units, for example, in length, where in the customary system we have an inch, moving to a foot, where we have 12 inches in a foot, then to a yard, 3 feet in a yard, and to a mile, where we have 1,760 yards in a mile. On the metric side, we go to a millimeter, where we have 10 millimeters in a centimeter. We have 100 centimeters in a meter, and then 1,000 meters in a kilometer. And so you can see all these units are based on 10. And we could go through the different ones as well with weight and mass, or with volume as well. But again, as I mentioned, where you don't really see a clear pattern between the different units on the customary side, that becomes very clear on the metric side, where obviously everything uses a base 10 pattern, which really makes that particular system really much easier to use unless you're very unfamiliar with it, like a lot of us are here in the United States. So we have different scales, and a scale is a device used for measuring distance on drawings. And we have our basic full fractional scale, which uses inches and feet. And so an example here would be a tape measure. It uses a fractional scale. And so on that, we can measure something and see that this is 14 3/8 inches long. And so the fractional scale uses the inch as its base unit. And so we have an identified length that is identified as an inch, and then we break that down further. So down here you can see an example. This is a full fractional scale. From 0 to 1 is 1 inch. And from there, it's fractional, where we break down 1, we divide into different smaller units by fractions. So we have the middle becomes 1/2, then we break it further, becomes 1/4, we can break it further to 1/8, and even further to 1/16, and we can actually go further. That can go into 30 seconds and 64ths and so forth. But the reason that different units, and typically the standard on a tape measure is a 1/16 of an inch, is the smallest unit, and so we can simply count the units 1, 2, 3, and that makes 3/16. Or if we were to go to 1, 2, 3, 4, 4/16, and then what we use is the process of simplification in terms of breaking that fraction down, when both the numerator and denominator can be divided by 2 and result in a whole number, both of them resulting in a whole number, we can break that fraction down into smallers. So where 4/16 would ultimately go down to 1/4. But that's why the units are what they are. So for example, 3/5 is not a measurement on our full fractional scale. The fifths is not a unit that we might use. And so with the fractional scale, we also have the engineer scale, where typically that is broken into also feet and inches. And but the difference here is that our engineer scale is going to break our units down into decimals. It's not a metric system, but it takes the feet and inches and puts them into a decimal unit. This allows for much more accurate calculations. For example, if we're manufacturing a part for an engine, that part might be 3.356 thousandths of an inch. And though we could break that to a fraction, that becomes a very, very complicated fraction. So the engineer scales allows us to use very accurate measurements for those. We also have the architect scale, which uses feet and inches. And these particular scales then allow us to, same with the engineer scale, it allows us to represent large scale structures, distances, accurately onto a small piece of paper, so we can scale things down. And then we also then have the metric scale, which it could be a centimeter scale, it could be a meter scale, it could be a kilometer scale, and so forth. Another system that we have is the American Point System, and this is a system that may be more useful or more used in this particular class in terms of graphic communication. And it is a system used in the printing and publishing fields. So when we talk about developing a newspaper, we talk about developing a magazine cover, that at its original or its a traditional method, we would use the American Point System to do this. In the point system, we use a line gauge to measure type and layout size. And what the American Point System allows for is a very small, accurate measurements as compared to, let's say, the fractional inch. So the American Point System was established because in the fractional inch scale that we might use with a tape measure, it was very difficult to come up with the small, accurate measurements that were needed. When you look at a newspaper, for example, the text and the spacing are all very, very small units, and so that was difficult to try to convert in terms of the fractional scale. So in the American Point System, it is made up of picas and points. And to kind of give you an example here, within a 1-inch distance, there are 6 picas, or there are 12 points in each pica, so there are 72 points in a 1-inch space. Now, you use points every day or often, but maybe you just don't realize it. But let's say, for example, when you're in Microsoft Word, when you go identify that you want to create text on this document at a 12-point font, that's the American Point System. What you are saying is you are identifying that I want to create text that's going to be 12 points tall. And if you think about it here, 12 points, and if there are a total of 72 points in an inch, essentially you are creating text that is about 1/6 of an inch large. And when you think about 12-point font on a piece of paper, that it is about 1/6 of an inch. And so when we communicate picas and points, we use a system here that uses the number, the letter P, and then another number. And so when the number is before the P, that stands for the picas, and when the number is after the P, that stands for the points. So what we would have here with 3P5 is 3 picas and 5 points. The 3P being 3 picas and P5 standing for 5 points. So as an activity here, you can see down here, and I know it's a little difficult to see, but where we have an inch here, and again that inch is broken into 6 picas, and then within each pica are 12 points. And so if we're looking at the measurement of this line, you can see here that it's past the 5, so we would have 5 picas, and let's say that it equals another 3 points past that line. And so if we were communicating the length of this line, we would communicate it as 5P3 for 5 picas and 3 points long. So you can see we have different systems, measurement systems that we have in place in order to communicate different measurements, and we have different organizations in place to help make sure that we have those standardized. The following lecture then will discuss how quality assurance ties into the different measurement systems.